Welcome to this series, लॉकडाउन लाइव सीरीज ऑफ विज्ञान भारती। मेरा नाम शेखर मांडे है। मैं काउंसिल ऑफ साइंटिफिक एंड इंडस्ट्रियल रिसर्च का महानिदेशक हूँ और आज के दिन हम लोग साइंस एंड टेक्नोलॉजी इन इंडिया थ्रू एजेस पे बात करेंगे। मेरा टॉक शुरू करने से पहले मैं ये बताना चाहूँगा विज्ञान भारती की ओर से कि ये जो लाइव टॉक सीरीज है आज के पश्चात ये हम लोग रोज करेंगे। तो हर रोज 5 बजे आप जरूर देखिएगा विज्ञान भारती की लॉकडाउन लाइव टॉक सीरीज। कल इस पे प्रोफेसर दिनेश सिंह जो दिल्ली विश्वविद्यालय के कुलगुरु रह चुके हैं, कल उन्हीं का टॉक इसी वक्त विज्ञान भारती पे 5 बजे होगा। नमस्कार। As I said, I am Director General of Council of Scientific and Industrial Research, and my name is Shekhar Mande. I gave this talk day before yesterday on the Vigyan Bharati YouTube channel, and I'm told that there were several interruptions during my talk, which were unfortunate, and I take full responsibility of that if the Wi-Fi at my place was not working very well, and because of which you are not able to listen to me completely. It was therefore felt that I give the talk once again. So if many of you feel that my talk is kind of repetitive of what I said the other day, I would like to apologize in advance to all those people who might feel that way. To begin with, first let me say that I belong to an organization called Council of Scientific and Industrial Research, which is a great organization of the country, has contributed a great deal to the development of country in many different areas of applications of science and technology to the development of modern India. It started in 1942. It was one of the first publicly funded research organizations of the country. It is a chain of 37 laboratories today across the country. I wear another hat, and that is my very fond association with Vijnana Bharati. I was a volunteer of Vigyan Bharati when I was a research student several years ago, but then more lately, I have also been associated with Vigyan Bharati as its national vice president. And therefore, I'm very proud that at this particular forum, I have a chance to share some of my views with all of you on science and technology in India through ages. Vigyan Bharati is doing a great work in taking science and technology, especially that happened in India, through the ages, including the modern work that the Indian scientists and technologies are engaged in, to common public. So this work is happening at a very large level. It's a voluntary organization, and a large number of volunteers who take great pains going to people and explaining to them what science and technology can do for the society. So I'm very proud of being a member of both these great organizations. Before I start, I want to give a couple of quotations. The first of the one is directly taken from Swami Vivekananda. Swamiji was one of the greatest personalities that our country contributed to the world. Swamiji quoted, and I'm going to quote, he said, "Experience is the only source of knowledge. In the world, religion is the only science where there is no surety, because it is not taught as a science of experience, and this should not be. There is, however, a small group of men who teach religion from experience. They are called mystics, and these mystics in every religion speak the same tongue and teach the same truth, and this is the real science of religion." And these are the very profound words of Swami Vivekananda. He goes on to explain that science essentially evolves out of our observations and experiences around us, and the experience that we have in the universe essentially teaches us about nature and about everything else. And we actually follow the same principle in science in our spirit of inquiry of nature. Now, before I go further, what science and technology does for the society or for a country, I would like to give one example of our neighboring country, and that is of China. Many of you recall, China had the Olympics in the 80s, early 80s, and during the Olympics, China very proudly demonstrated its achievements through the ages. Just like India, China has been a great world power in its culture, in its history, and its contributions to the society, in contributions to humanity. And China very proudly at that time advertised ancient China's achievements, that is compass, printing press, paper, and gunpowder. Similarly, we should also be very proud of all the work that has happened in India through the ages, and that's what I'm going to talk to you today about. We should also remember that in 1978, when Deng Xiaoping took over the Chinese administration, he proposed four modernization theories. He said that modern China would be based on four pillars, and the four pillars were agriculture, industry, national defense, and most importantly, science and technology. And therefore, China serves as a very good example for a country which can make great strides for its people if we adopt science and technology as the vehicle of our progress. And that's exactly what our country also should be doing that. Now, before I start my further talk, I would like to acknowledge certain people who have motivated me to give this kind of a talk. I must state that I'm not a great expert in the history of science, particularly that happened in India. But whatever little I have learned is through my conversations with stalwarts such as Professor Rodam Nasima in Bangalore, Professor M.S. Valiathan, who currently lives in Manipal, Professor Subhash Kak, who lives in the US, and so on and so forth. I would also like to refer all of you to some of the books which are very important books in this particular field, especially compilation of 17th and 18th century records by a person called Dharampal, published by Other India Press and SIDH. And the Dharampal's book is very illuminating in what was a tradition in India in science and technology. One of the very pertinent questions that Dharampal addresses in his books is why have SNT, which have been very much alive until 8 to 10 generations ago, been eclipsed in our country? And the reason that many modern day philosophers give that to the economic breakdown between 1750 and 1900 in India. Now, this particular point is also very much emphasized by two contemporary authors. And the two contemporary authors are one Mr. Shashi Tharoor. And Mr. Shashi Tharoor has written a very readable book called An Era of Darkness, and in which he chronicles everything that happened in British era, which essentially robbed us, our population, of our culture, of our traditions, our education, and our thinking process. It's a very powerful argument that Mr. Tharoor has actually proposed in this particular book, and therefore it's time to go back to our roots, to our culture, and ask ourselves that if we have been such a great culture, why can't we build our society based on what our ancients have been telling us till the 18th century? Similarly, there's another very good book that I would like to refer people to, and the book is titled Anarchy, and it has been written by William Dalrymple. And once again, it's a very, very readable book. I would like to refer people to these books as a text of my particular talk today. Let me now begin of how people living in the geographical region that we call today as India or Bharat have actually been very curious people, have been always exploring nature around them, and have contributed very richly to the world of knowledge as we know today. And I pick up my example from about 30 to 50,000 years ago. And this example is when people had even not started forming colonies, people were still living in small groups. They were called hunter-gatherers, and they used to live in groups of about 10, 15, 20 or so, and daily go and hunt around and make their living out of that. The societies came much later. The formation of societies is only about 12 to 15,000 years ago from today. But the example that I'm quoting is about 30 to 50,000 years ago, and this is based on an evidence that is present even today in a place called Bhimbetka, little bit south of Bhopal. If any one of you has had a chance to go to Bhimbetka, this place is very rich in the rock paintings there. And it's a very beautiful example of how people used to live at that time and how people used to have recreation in paintings on the rocks about the world, what they saw around themselves. Now, these paintings have survived 50,000 years ago, is a tribute to those people who actually generated colors from natural colors around them, from whatever they could gather, from vegetables, from stone extracts, and so on and so forth, and made these paintings which have endured the planet for so long. So it's actually a fascinating example at how human beings have always been exploring nature around them, and especially people in our region have been exploring nature around them during that particular period. I now come to more recent example, and when I say recent, the example is still about 5,000 years old, and this example actually highlights one very important fact, and the fact is that many of you know that there are two very important trade routes that existed between eastern nations of India and the western nations of India. From the eastern nations of India, in the up north, the northeast, there was a very famous silk route that used to traverse all along the Himalayas and then go to the western nations in the of the world, especially the Arabian countries and the Central European countries. And the Silk Route actually was a very famous trade route through which people would trade whatever they had along with them. Similarly, there existed a spice route that went once again from the southeast part of India, the nations of the southeast of India, and nations which are part of Africa, and once again Arabian nations. And the spice route essentially was a sea trade, and that also passed through India. India formed as a very important intermediary in the spice route. India was also important mediating point in the Silk Route. So both these routes, India actually was placed very centrally, and therefore it was natural that there also would be a connection between the spice route and the Silk Route. And this natural connection actually went through the modern day Punjab and Sindh that connected them. But the sea trade was so important, and today if we go to a place called Lothal, about 100 kilometers south of Ahmedabad, you see existence or in the evidence for a very old seaport that existed in Lothal. The seaport was excavated by Professor CSIR Rao in the 1950s, and it is datable to about 2,500 BC. The seaport is a very brilliant example of how people in our region were very active in the trade between the nations which were east of us and between the west of us, nations which are west of us. And people who lived actually in our part of the country, therefore very important intermediate points in the thriving trade between the two parts of the world, between the east and between the west. It's therefore very natural that people of India, Bharat, were very active in developing many different ingenious ways of science, technology, and development of the society. It's but natural that many great civilizations arose then in our part of the country, and excavations from Harappa, Mohenjo-daro, and more recently Rakhigadi, Lothal, etc., are brilliant examples of the excavations that happened with the civil society that existed even then. The society planning, the planning of the cities had their very extensive network, the city's network of the drainage systems, the water distribution network, all of it are great examples of the culture that we today have inherited from those people. I would like to mention one name, Professor Vasanta Shinde, a great archaeologist of modern India. Professor Shinde has been arguing in many different places that this culture has been continuous since then till today. And he gives many different examples, he quotes many different examples of how this culture is evolving and how we have inherited some part of the culture from that particular era even today. Let me now go ahead and talk some specifics of science and technology. And I would like to give you examples from different aspects or different disciplines of science and technology. And I would like to start from mathematics and astronomy. All of us have heard that mathematics was greatly developed in our country. There are many different contributions of India that are talked about all over the world. All of you have heard that discovery of zero is attributed to India. All of you probably also would have heard that the discovery of the decimal system that we use today is also attributed to India. Although we call it Arabic numerals, they actually were discovered in India. And an example of that is quoted by Fibonacci. Many of you would have heard the series called Fibonacci series. And Fibonacci was an Italian mathematician, and he credited bringing the decimal system to Europe in about 1200 AD. And Fibonacci is supposed to have quoted a quote, "The method of the Indians surpasses any known method to compute. It's a marvelous method. They do their computations using 9 figures, 1, 2, 3, 4, 5, 6, 7, 8, 9, and the 10th one is a 0. And that's how the decimal system works. It's a beautiful example of how decimal system India brought to the world of mathematics. All of us have heard of many great mathematicians in Indian history, whether be it Aryabhatta, or whether it Bhaskaracharya, or be Madhava. All of them have made tremendous contributions to the world of mathematics. Aryabhatta wrote a standard treatise called Aryabhatiya in the year what we call today as the Christian era 499. About 500 AD is Aryabhatiya, which is written, in which Aryabhatta quotes saying that he was 23 years then, and the age that he computes himself as, he says, that when 60 times 60 years and 3/4 of the Yuga, what now we call as the Mahayuga, had elapsed, I was 23 years since then, since my birth. Now this is remarkable. Aryabhatta calculates the beginning of Mahayuga, which is 60 times 60 years and 3/4 of Yuga before his birth. It's absolutely remarkable because of the fact that it is now estimated that the legendary Kali Yuga began in the year 3102 BC. Now, the dating of the beginning of Kali Yuga is based on the texts and on the planetary positions of at that particular point of time. Now, we must remember the planetary position calculation is extraordinarily complex. It's not a very easy method to calculate how would be planetary position so many years ago. Moreover, we should also remember that Earth rotates around an axis. All of us know that. The axis points toward the pole star, what we also call as Polaris, and therefore the pole star appears to be stationary while the Earth rotates around its axis all the time. What all of us should also remember is that this axis precesses like this. It is not stationary, always pointing to the pole star, but the precession of this axis, and the number of years that it completes one precession is about 26,000 years. And therefore, the positions of the planets and the constellations and the stars, they change over a period of time. And it's remarkable, therefore, that Aryabhatta was able to calculate the positions of the stars and planets, which is so many years before his birth. Aryabhatta's own estimates that Earth rotates around its own axis in 23 hours, 56 minutes, and 4.1 seconds is a very close estimate of modern day calculations. It's remarkable. In 500 AD, Aryabhatta had predicted, or Aryabhatta had calculated, that Earth rotates around itself in 23 hours, 56 minutes, 4.1 seconds. Now, most of the Western philosophers and mathematicians find it very difficult to believe that these calculations were done more than 1,000 years before people like Pascal and Newton and Kepler came into being. Aryabhatta also estimated the correct value of pi, which is very close to the correct value of pi. I would like to also quote about another great mathematicians of India, and it is Bhaskaracharya II. Now, Bhaskaracharya II lived very close to Jalgaon in Maharashtra, modern day Jalgaon in Maharashtra, in a place called Patan Devi. And there is still a temple which is devoted to Bhaskaracharya at Patna Devi. And he wrote two very classical texts of mathematics. One is called the Bijaganita and one is called Lilavati. And Colebrook, a very famous Western mathematician, has quoted about Aryabhatta and Bhaskaracharya, and I am going to quote, "Had an early translation of Hindu mathematical treatises been made and given to public, especially to the early mathematicians in Europe, the progress of mathematics would have been much more rapid, since the algebraic symbolism would have reached its perfection long before the days of Descartes, Pascal, and Newton. Unquote. And that actually tells you that Bhaskaracharya, who lived in the 12th century, and Aryabhatta, who lived in the 5th and 6th century, would have actually changed the face of mathematics, or probably would have accelerated human evolution of understanding nature way before the modern European mathematicians came around. That's absolutely fantastic that these people existed even then. The school of mathematics, of course, shifted a little later in the 15th century to the deep south in Kerala, where once again the stories of Madhava School of Mathematics are very famous. And Madhava School of Mathematics actually had knowledge of modern day what we call as differential and integral calculus, and which is absolutely remarkable because apparently there was no communication between them and the Western philosophers, and it was completely done here. And had Western philosophers been aware of the work of Bhaskaracharya, Madhava, and so on and so forth, probably mathematics would have made progress much more rapidly in the early days. Let me talk of a few examples of metallurgy, but not before quoting one very interesting fact about computer sciences. Because computer sciences are so closely linked with mathematics and astronomy, the modern day computer science is actually built on the firm logic theory of mathematics. And the programming in mathematics, programming in computer sciences, actually there are many different people who have contributed to the programming. And there's very one famous theorem in computer science, which is called the Panini-Backus theorem. And actually what the Panini-Backus theorem. And what we should be aware is that the common language, spoken language then, in most part of India was Sanskrit. And Panini actually had developed the Sanskrit grammar and a theory of grammar, which is finding its root, its contributions, even in modern day computer science. It is once again very remarkable that people find the contributions of Panini even today in the modern sciences. I come to metallurgy now. India also was known to have great contributions to metallurgy. Many of you would have heard of the Damascus sword. The steel made in Damascus sword was famously, the process for that was made in India, and then it traveled to Damascus, where actually these very famous swords were made. And that's a very acknowledged fact that many people around the world know of. But I go even much before, about even 2,500-3,000 years before that. And I go back to the era, once again, of Harappa and Mohenjo-daro. Among the many fascinating discoveries that we have made in the excavations in Harappa and Mohenjo-daro, one is a very famous statue called the Dancing Girl. Many of you would have seen the Dancing Girl in the textbooks, or some of you would have also seen the statue actually in the museum in Delhi. It's a beautiful statue. The statue is made by blended metal, which tells us that people about 3,000 years ago or about 5,000 years ago knew how to blend different metals. Apart from that, people also knew how to cast metals, and the technique called lost wax was used for making the statue was known even then. Now, I told you about Professor Vasant Shinde's theory that culture is continuous, and we have inherited many things from that particular era. The lost wax technique is even used today for making things like statues and objects, ornaments, and so on and so forth. And this was developed about 5,000 years ago, even then. And it is once again very important aspect of metallurgy of olden period. All of you would have heard more famous examples like the pillar near Qutub Minar and so on and so forth. So let me not talk about that, but let me also tell you that when the British came to India in the 18th century, they discovered that there are processes of making steel in parts of India, and especially places near Jabalpur and all, where the Agaria community was making steel using very well-developed furnaces and so on and so forth. And the British made very careful recordings of this, and all these recordings were eventually presented to the Royal Society, that what is the process that Indians make steel of, and how Indian steel was considered to be better steel than that of the Sheffield steel that was being routinely made in the UK. There's another recorded history fact that in the 18th century, before the British came to India, the process of making steel and all was very well developed in the Indian subcontinent. I would like now to go to shift from my focus of my talk to agriculture. This is another great example of how people living in our country had developed great methods of agriculture. Now, this have been actually recorded in many different records, and I'm going to give you a few examples of this particular one. The two examples that I would like to quote. One is a record by Major General Alexander Walker in 1820. He made this particular record, and let me quote: "The Hindus have been long in possession of one of the most beautiful and useful inventions in agriculture. This is the drill plow." Unquote. Similarly, there is another quote by Captain Thos Halcott in 1795, and he realized that a drill plow is an unimaginably useful tool, and he quotes, "Until lately, I imagined drill plow to be a modern European invention, but a short time ago, I found out that it has been in use here for time immemorial." Unquote. This actually tells us that the people living in the Bharat actually knew how to use tools for their own purpose. And they used to know actually many different cropping cycles during the year. They knew the techniques of co-cropping, and they actually knew how to fallow the land and so on and so forth. So agriculture was a very highly developed endeavor in India at that particular point of time. It also reported that the rice productivity in India then in 18th century matches the highest rice productivity in the world today, that is there in Japan and China. So the rice productivity being so high is also another very remarkable features of Indian agriculture from that particular point of time. And from the archaeological point of view, I would like to tell you that one of the oldest dams constructed and still in use actually exists in Trichy, in near a place called Kalanai Dam. It's constructed on river Kaveri and is still in use. That's a remarkable example because Kalanai Dam was constructed in the first or second century AD, and is still the oldest dam still in use anywhere in the world. This dam was constructed by the Chola kings then to use irrigation as the principal use of this particular dam. It's quite remarkable that agriculture was so highly developed in our population. Our population commonly harvested wheat, barley, jujube, so on and so forth. Our population had domesticated sheep, goat in the pre-Indus civilization. It's also known that elephants were used by our population in the armies and so on and so forth. There were 2 harvests a year. The fallowing of land and a very well-developed irrigation system have been characteristics of our culture. Sugarcane farming and Kislev sugar was known to Indians in 300 to 500 AD. Now, these are all known, recorded historical facts. And that tells us how well developed our society was in terms of science and technology, but also science and technology was an integral part of our culture, of our everyday living. So we must go back once again to make this particular culture and bring science and technology as our part of everyday culture. I want to give a beautiful example of innovation. When science and technology is very highly developed, people start innovating about making their life easier, and these innovations are the ones which eventually drives humanity. All of us are aware of that. And a great example of innovations is something called Gharat. Some of you would have seen it, some of you would have heard of it, but Gharat is a kind of a flour mill that exists in entire foothills of Himalayas across India. So you start from Jammu and Kashmir to Himachal Pradesh to Uttarakhand to Uttar Pradesh to Sikkim and to Northeast, the entire belt of Himalayas, at the foothills of Himalayas, Gharats are very commonly used all across. Now, Gharats are the flour mills. Some of you would have seen, those who live in the south, we know that the flour mills are typically used by manual operation. Our grandmother used to do this to grind flour every day from either wheat or from java or so on and so forth. But people in the hills discovered that there is falling water. So there's water streams which falling down have tremendous energy in that. And if you can design certain gears so that falling water can rotate a stone wheel something like this, and you put another stone wheel rotating on the top and put grains inside, what you will get is the flower out of that. And it's an amazing example of innovations. And trust me, Gharats have been known to exist in the foothills of Himalayas since 7th century AD. About 1300 years ago, our people knew how to make gharats. They had generated very sophisticated gear system, and they used to use gharat until very recently. In fact, there are still many people who use gharat. They take their wheat or something to a gharat and grind their flour and come back home. It's quite remarkable that this particular process was known to us or was evolved in the foothills of Himalayas then. I want to come now to the field of medicine, and after that, I will rather stop. This is the last example that I want to give. I don't want to talk too much about medicine because there are many people amongst us, even who are members of Vijnana Bharati, they are much more knowledgeable about our traditions of medicine, especially Ayurveda. And all of you have heard very interesting talks by Professor Bhushan Patwardhan yesterday and one 3 days ago on some aspects of Ayurveda. And therefore, I don't want to go very deep into that. He has also told us beautifully how some of the ancient practices have been very useful. And if we go back to them and attempt to show that from the modern science perspective, how useful these practices can be, even in the modern day use, I believe we'll have a very powerful way of changing the way we live even today. Now, one of the earliest examples from Indian subcontinent and archaeological evidence comes from several years ago, about 7.5 to 9,000 years ago. There was an excavation done in a place called Mehergarh, and in the Mehergarh excavation they found certain skeletons, and in the skeletons they found that the tooth of certain skeletons were drilled, and that actually becomes one of the earliest examples of Neolithic tradition of dentistry. And flint tips were surprisingly found to be effective for drilling tooth enamel in this particular period, even as early as 9,000 years ago. But as I said, much later, all of us have heard of Sushruta and Charaka, who actually wrote down many different aspects of medicine. And all the aspects that Sushruta and all wrote were not necessarily discovered by them, Sushruta or Charaka, but also were building up on the knowledge by many other people who had built up till then. And as I said, I began my talk by quoting Swami Vivekananda that we must learn everything from experience, and that's exactly what Sushruta actually chronicled in his textbook. He actually learned from experience many of those, and he has written down those beautiful texts. Ayurveda is a synthesis of two words, Ayu, which is life, age of longevity, and Veda, which is know or knowledge. So Ayurveda is the knowledge by which healthy human life in all aspects, physical, mental, intellectual, and spiritual, lives to its fullest. And there is another great addition of our country that we recognize that progress in science and technology must be linked to our mental, intellectual, and spiritual development. I should mention here that I had a chance to meet His Holiness Dalai Lama a few months ago, and His Holiness Dalai Lama told me that as scientists, we actually address only the material world around us. And he said that is how the science has been taught to us in recent times, the modern science has been taught to us in recent times. And he said there is a need to go back to our ancient roots, there's a need to go back to our culture, which was so highly developed in this part of the world till about 18th century. And he emphasized that science and technology must be integrated not only to the physical world around us, but also to our mental, intellectual, and spiritual development for the development of a human being. And if we adopt our traditions, if we adopt our culture as it existed till 18th century, I am sure we will have a chance to contribute a great deal to humanity by integrating modern science and technology to the overall development of humanity. I want to give an example of how developed was our science and technology in the 18th century. And I quote from from an article written by J.Z. Holwell, a very famous physician who lived in the 18th century. He came to India, and when he went back to UK, he read a paper before the Royal Society, and he addressed his paper to the president and members of the Royal College of Physicians in 1767. And in this paper, he details in with great meticulous observation that there exists a practice in India of inoculating people against smallpox. Now remember, Edward Jenner came much later, about 30 years later after this paper was read, to the Royal College of Physicians, and the smallpox vaccine, as we know today, was developed in 1798. But the account of J.J. Holwell goes in great details, very minute details of how vaccination was practiced in India. He states that there are three essential seasons that exist in West Bengal. He had done his study in West Bengal. He said that from mid-July to mid-October, there's a season in which we receive a lot of rains, winds, and so on and so forth. From mid-October to mid-February is a season which is somewhat cold, not as cold as what Europe has, but nonetheless a cold season. And then from mid-February to mid-July is a region where there is a lot of warm environment. And it is in this season that many of the diseases actually start surfacing. At the beginning of this season, he wrote down that great scholars descend upon all parts of the country. They go all over India, starting from Banaras. These people actually have been trained in Banaras on how to practice the modern day living and medicine. These people go around in Bengal, according to his account, inoculating people against smallpox. But those who are inoculated against smallpox have to follow certain routine 1 month before all these learned people from Banaras come to their place. And the routine that they have to follow is they have to avoid drinking milk, and they have to avoid eating fish, and they have to avoid eating oily food. Now remember, rice and milk and fish were common food of the people of Bengal in the 18th century. And therefore, avoiding milk and avoiding eating fish was actually depriving people of their common way of eating. But nonetheless, the physicians would insist on abstaining from this food at that time. And Holwell asked them, why do you think that people should not eat this food? And many physicians said that although the reasons were not clear to them, they suspected that milk and oil is very readily absorbed in the body, and they don't want body's metabolism to be affected before inoculation is carried out. What these people would carry with them are long needles. They would go to people who are affected by smallpox, take a small inoculum, and go and inoculate what we call as vaccinate today the healthy people. And therefore, the healthy people would never develop smallpox in their time. This is precisely what Edward Jenner eventually discovered 30 years after this account was made. So the practice of vaccination was very prevalent in India even in 12th century. In fact, China and India, they were known to have this practice regularly, where learned people, the medicine people, would go around different houses and vaccinate people against certain kinds of diseases. So we should be very proud that this kind of practices were even known much before the British arrived in our country. I talked about Ayurveda. It was very widely acknowledged in the West that knowledge depicted in Ayurveda is very rich, and there is a lot of knowledge in India also from the tribal way of medicines, and that also must be explored the way modern medicine is developed. And I'm going to tell you about a story about Henry Wellcome. Henry Wellcome was a very well-known pharmacist. He started a company called Wellcome Group. Wellcome Group eventually merged with the GlaxoSmithKline and became GlaxoSmithKline. But all the money that he had generated in his lifetime, he donated to a charity called the Wellcome Trust in the UK. And today, the Wellcome Trust is the largest biomedical charity in the world, which funds basic biomedical research around the world. And the manner in which Wellcome generated knowledge is also very revealing. Wellcome sent a medical entrepreneur, a doctor, and a linguist called Paira Mall, a doctor of Indian descent, Paira Mall, to go to India and to scour India for diagrams and manuscripts, that would reveal the art and science of healing through the ages. Unquote. Welcome infamously told Moll not to return until, quote, India is completely ransacked as far as we possibly can for literature and other objects of interest connected with ancient medicine. Unquote. Now, this is in 1911. That is in the early days when the modern medicine was developing. Even today, many of the companies around the world acknowledge the fact that there is merit in the rich Indian texts that exist and the rich medical practices that are followed by practitioners of Ayurveda, Siddha, Unani, Savarigba, and so on and so forth. And therefore, is the duty of our present day generation people to try to see how we can exploit this knowledge that has been developed through the ages in India and try to see whether we can make our living better by using this knowledge of Ayurveda and Siddha and Unani. Ministry of Ayush is doing great efforts in this. Our good friend with Rajesh Kotecha is very keen on saying that many of the principles of Ayurveda can also be actually shown to be proven from the modern science perspective, and many of us are actually trying to do that in this particular respect. I'm almost at the end of my talk. I began by telling you from a quote from Swami Vivekananda that we must learn by experience. That has been our science, that has been our culture, that has been our tradition. That has been the tradition of the people who have lived in this part of the world for thousands of years. That is the tradition that we have inherited. That is the culture that all of us have inherited. And we must follow that in its true spirit and inquiry. We must understand that we have had a great tradition, and we should try to integrate this tradition in the modern human development by integrating the knowledge of spirit as what we do for our material world by science and technology. That's all that I have to say. Thank you all for listening to me. Thank you very much. Namaskar.